Thanks, Mr. Vikas. It was an excellent presentation. Pratap from Reliance. Mr. Aniket, request you to come on the stage.
Good afternoon, everyone. My name is Aniket Pratap at Reliance Industries. I'm a part of the New Energy Initiative by Reliance. What we are going to talk about today is how the world is getting transitioned from the existing energy system to the new energy system. Right now, the world is using hydrocarbon mainly, and we are going to go towards hydrogen. The main agenda here is to make sure we are carbon neutral. Our chairman has set up a very challenging role of becoming carbon neutral by 2035. India has also signed the Paris Agreement. The entire world GDP is working towards making a carbon neutral world where greenhouse emissions can be cut down. So before we start, I just want to narrate a small story. Like, if you look into the world energy transition, this is what the world does today. We go to the center of the sea, we go to some oil field, we produce crude oil, natural gas, we transport it to the processing stations like refineries. We have one big one in Jamnagar as well, if you don't know. And then we go to the distribution area like petrol pumps, cylinders, and these three are the primary technology using which we consume the fossil fuel right now, the petrol engine, the diesel engine, and the gas turbine engine. How we generate electricity, we use gas turbine engine. How we generate mobility solution using petrol and diesel engines. But in this entire scenario, one thing which happens, which is inevitable, is the emission of greenhouse gases. So what we are going to do for that? So this is the new plan. This is so far called the hydrogen economy or the hydrogen ecosystem. What we are going to do, that we are going to use renewable energy. India is blessed with a lot of solar and wind energy. We are going to take leverage of that. We are going to produce electricity out of that. We are going to use that electricity to store in the batteries. But, batteries are one part of this, but there is another very important part, that is we need the inventory of this energy. The electricity which is coming in this building right now is being produced on demand, like continuous. If a dam stops working there, if a generator stops working there, this will go away. So we need to create the inventory of energy. What we are going to do to create the inventory of energy, we are going to store it in the battery. Other way is we are going to split the water using electrolyzer and this renewable energy into hydrogen and oxygen. This process is called electrolysis. This hydrogen will be transported via hydrogen pipeline and will be stored in these carbon fiber tanks. And then they will be consumed by fuel cell electric vehicle and hydrogen internal combustion engine for the mobility solution. And also the battery technology will be used for the mobility solution in the battery electric vehicles. There is a catch here. If we can store everything in battery, then why to go for hydrogen? Battery has its own advantages and disadvantages. If you want to make an aeroplane run on battery, the weight of the aeroplane itself becomes very, very high. All the efficiency of the aeroplane will go away. Hydrogen is a very lightweight element which can help in storing this energy. And using technologies like fuel cell, we can make the mobility go. So we will talk about fuel cell today. And before we talk about fuel cell, let's look into what kind of fuel cell technologies we are having. So for mobility application, which we are dealing with right now, we are going to use the PEM fuel cell technology. What is a PEM fuel cell? Like, we will not get into the chemistry part of it. I don't want to make it a boring lecture. PEM fuel cell is a device which takes hydrogen and oxygen and convert that into electricity. We feed hydrogen, we feed air. The hydrogen gets split into H plus and electron. Hydrogen reacts with oxygen to make water, and we get electricity, which has been shown here. So the output of this system is electricity and water. There is no greenhouse gas emission here. This technology is the most sought-out technology for the mobility as of now. There are other fuel cell technology as well, phosphoric acid, solid oxide, and molten carbonate. I'm not going to go into everything, but this guy here, the solid oxide fuel cell technology. This is also a very interesting technology which is being used in marines, in the sea vessels. So PEM fuel cell technology and solid oxide fuel cell technology are the two main technology which is going to shape the future of mobility, future of power generation. Maybe in the future, 10 years down the line, or maybe 5 years down the line, your building will have a fuel cell system with a hydrogen line connected to it, and it will generate electricity on site. This concept is called distributed energy or distributed electricity generation. We may not depend on a central big power grid. These technologies will make it possible for everyone, everywhere, that how much energy you want to use, you can generate it on site and you consume it. Same will go into the mobility or cars and trucks, especially trucks and buses, the big vehicles where battery has a limitation of weight and energy density, and these will convert the hydrogen into electricity on site, on the vehicle itself. And the only emission would be water. So let's look into what does a fuel cell system consists of. We all know how an internal combustion engine works. We know that we burn fuel, the piston moves, crankshaft moves, the wheel rotates. How a fuel cell system works? This is a PEM fuel cell stack. You can get it from the market. As I explained, you need to feed hydrogen to it. So we store hydrogen in the hydrogen tank at 350 to 700 bar. We feed it to a hydrogen flow control system, which I'll describe that how Emerson has partnered with Reliance to develop this technology. This hydrogen goes inside the stack. We don't use all the hydrogen. We have a recirculation loop, which is there to increase the efficiency. There is other subsystem, that is the air subsystem. What it does, that it controls the flow of the air through it. It controls the humidification of the air. It goes inside the PEM fuel cell. It generates electricity. When electricity gets generated, what happens? That it gets heated up. So we have the third subsystem. And this is called the thermal management system. It is connected with a radiator, a heater. For starting the fuel cell, we need to heat up the fuel cell also for some time. And once you feed hydrogen and air to a fuel cell, what it generates? It generates power. But this power is like what it, if I give you an example, it's like a solar panel power. Like it's not consistent. It sometimes goes up, sometimes goes down. So what we do, we condition the power. There are people from different area of this industry. They know that how power conditioning is done. This is basically a DC-DC, and then we get a usable power. So in order to achieve this, what we did, we have developed a solution to reduce this 350 or 700 bar pressure to a usable 10 to 25 bar pressure using a dual stage pressure regulator. Emerson helps us in building this. This 10 to 20 bar of pressure is fed to a hydrogen flow control system, which essentially consists of a valve, a pressure transmitter, and a lower pressure control valve. Like this 10 to 25 bar of pressure is using this device, gets converted into 0 to 3 bar. So this is the device which controls how much energy you inject inside the PEM fuel cell system. It is equivalent of an injector of an internal combustion engine. Similarly, for the, there is an anode and drain purge system which consists of rapid reaction valves and a water separator. In the air subsystem, we have motorized valves, we have an air compressor, and most importantly, an air humidification system. And as we progress into the development of fuel cell system, we'll come to know that the radiator system or the thermal management system of fuel cell is a little bit different than what we use it in. Oh, 1 second, someone is disturbing me. Okay. what we use in a normal truck. We cannot just simply rotate any coolant through it. This coolant has a potential to carry charges with it. So we need to deionize this coolant. So Emerson has also supplied a conductivity meter for the thermal management system. So if we want to put all these things together in a in a vehicle, we need to make sure that this is modular, less in size. This is the electrical connections of this are POK, OK, EMI, EMC compliance, and most importantly, this is a very interesting area where the process industry and the mobility industry are merging their technologies together. Now, if you look into this system, this is the entire fuel cell system which can generate electricity from hydrogen, and this is all you need to convert or to build a vehicle which can run on hydrogen, an electric hydrogen, fuel cell electric vehicle. But right now, what is the limitation here in India, or even in the world, I would say, that one can get a PEM fuel cell stack from a manufacturer, but one has to put a lot of engineering in all these things. This is called the design of the BOP, the design of the balance of plant. But what we are working with Emerson and many other suppliers is to modularize these things. What we really want India to do is that everyone should get used to start consuming hydrogen or generating electricity out of it. So one can take a fuel cell stack, one can go and we will modularize these entire balance of plant from hydrogen, air, and thermal management system. They can collect it, they can purchase it from any of the vendor, they can integrate it, and just like a battery electric vehicle, anyone can manufacture this. This is the big vision, because in order for these technology to succeed, it's very important that hydrogen production and consumption go hands in hand. If we are only generating hydrogen and there is no consumption of hydrogen, there is a problem. There is a lot of consumption of hydrogen, like such products are there, but there is no production of hydrogen, there is still a problem. So that's why this world is not transitioning very fast towards hydrogen. But as such products will go in the market, the hydrogen consumption and production both will get into sync, and we will be able to generate clean electricity and clean mobility technology using such things. All right, but in order to do these things, we also need to test the system. So we have also built a fuel cell test bench where we need to find out that at what RPM of a blower, how much coolant is flowing, how much air is flowing, at what pulse width modulation of a valve, how much hydrogen is flowing. So we got Coriolis flow meter connected with pressure control valve, and these feedback mechanism, using these feedback mechanism, we made test setups in our Bangalore facility. This is one of the state-of-the-art fuel cell system testing facility which we have developed at Reliance. We mostly use the Coriolis flow meter and the Vortex flow meter. Now, Vortex flow meter is a very essential, the testing of fuel cell system, especially for the airline. I said that air need to be humidified. If we see any other flow meter which, has a dual media or which has a, steam mixed with it, it may give error. But Vortex flow meter can handle this. So we are using that. There is another interesting application, that is the application of how we are going to refill this vehicle. What we are going to do that using electrolyzer, we are going to generate hydrogen. This hydrogen will be at a lower pressure, 40 bar approximately. Using a compression cycle, we are going to put it into the storage bank. It will go to a dispenser. Compression cycle will take it to 300 to 700 bar, and then it will be fed to the fuel cell electric vehicle. If I show you in a block diagram approach that what exactly this means the electrolyzers will use renewable energy, split water into hydrogen and oxygen. This hydrogen will be stored at generated at 20 to 40 bar. Will go to a hydrogen compressor, it goes to 900 bar, then it goes to a dispensing station, and pretty much like a CNG refilling, this hydrogen will get into the hydrogen vehicle. And the vehicle will run on electricity, not on hydrogen combustion. There is another product called hydrogen internal combustion engine. Their combustion will happen. But what I'm talking about is the fuel cell electric vehicle, where this hydrogen will directly be getting converted into electricity. Of course, there are multiple instrumentation. And I should reiterate this thing, that this technology is not a very new technology. This has been used in Apollo missions when people went to moon and all. The main roadblock for commercializing such technology is instrumentation and the controls element. So I would request all the OEM of instrumentation to think through these things and come up with products which are modular in nature, which can get integrated with each other. I would truly like to thank Emerson that they have partnered with us in building this modularization system. I hope in the future we'll have hydrogen, air, and thermal management system in a modular way. One can directly go and pick it and assemble this to make any kind of fuel cell system. Some of the critical instrumentation which is essential for the testing and for the manufacturing of such technology, either in electrolyzer or in fuel cell, is coreless flow meter and vortex flow meter. Coreless flow meter is very much required because this is the one which makes sure that the energy is being metered properly. This is one of the highest highest accuracy meter in the market available as of now, and I'm quite satisfied with the with the technology which Emerson has provided. And vortex, I have explained that why it is necessary because of the humidified media measurement. The two-stage regulator is another important component. We need to make sure these fuel cells are quite notorious. Like if you feed hydrogen and they have pressure variation into it, their voltage will vary because this is an electrochemical reaction going on. We need to make sure that the hydrogen delivery is very much consistent. So this two-stage regulator was a big win for us. We have pneumatic pressure control valve and three-way and two-way valve. I just have the photo of the bidirectional valve, but in the thermal management system, the three-way valves are also used. And I would like to end up with saying that in this market of new energy, right now there is no competition. And more people who will come to this new energy business will make this more viable. Our competition is not each other. Our competition is greenhouse gases. If we can do something to reduce that, anyone, any technology, anything which we can do to make such concepts a reality is most welcome to join us. And I would like to thank all of you to give me this opportunity, especially Emerson. Thank you.